Hello, Mr. Pizarro here. So the purpose of this video is for you guys to get used to going from an input to an output to graph a function. And it's something that you've probably done a little bit before, but hopefully we'll take you to the next level today, and if not, review at least what you've done before. So let's think of a function. A function is generally could be thought of as a rule, and we're going to formally define a function and test to see if something's a function later on in the unit. But for right now, let's think of it as a rule. So if we've got maybe y equals 2x minus 1. We'll keep it kind of simple. That's an example of a function. It's a rule that gets you from a potential input to an output. Now, we could also use function notation. I want to point out, though, the only reason I'm using x and y is because we're using x and y's on our graph over here. This, again, is our x-axis and our y-axis. So really, any letters could be used. And a lot of the patterns we're going to be doing, you'll be asked to use n instead of x. And I guess it just doesn't matter. N is generally reserved for, the nth term in a pattern. And we'll look at that later as well. But for right now, let's keep the y and the x. Something you also might see is somebody might write this as the function of x equals 2x minus 1. And so f of x, meaning the function of x, it just basically takes the place of y. Otherwise, it means the same thing. So in a situation like this, I'll go ahead and erase this and we'll stick with y for now. In a situation like this, what I'm going to ask you guys to do is actually to create a table. Let me move this over just a bit. And so the table you create might look something like this. You can take your rule or your equation and start coming up with potential inputs. So this over here, this is going to be my x inputs, and my output's going to be in the middle because that's going to be y, and then I'm going to actually end up with my coordinate to graph. Okay, so it doesn't matter what we put in, but I want to choose inputs that are going to be, graphable for me because I don't have an infinitely large graph over here. So I always like to do at least a negative, 0, and a positive. Maybe we'll do even more than that. So let's start out with a negative number. Let's say, what happens to y when x is negative 2? Well, that would be y equals 2 times negative 2 minus 1. We do the math on that, and y equals negative 5. Because 2 times negative 2 is negative 4, minus 1, negative 5. So we have the point when x is negative 2, y is negative 5. And so we want to do another input. Again, I said normally I like to do 0. So if x is 0, we would plug that in. Y equals 2 times 0 minus 1. Y just equals, well, negative 1. Because 2 times 0 is just 0. So now we have the point 0, negative 1. Okay, let's come up with a positive number. Let's try, positive 3. Doesn't really matter. So y equals 2 times 3 minus 1, or y equals 5. So now we have the point 3, 5. And when we go about graphing these, remember the first number, the x, is what tells us to go left and right, and the second number tells us how far to go up and down. So starting at the origin, my first point, I'm going to go left 2, and I'm going to go down 5. That's how that works in case you've forgotten. So down 2, or excuse me, over 2 and down 5. 1, 2, 3, 4. It's hard for me to see this. It's small. I must be getting older, my eyesight. I think I did that right. So now we want to graph 0, negative 1. Again, 0 told me I didn't have to go left or right at all. Just stay right there on the y-axis. And then 3, 5. And as you can see, those 3 points are on a line. And I just want to ask you, is there any number for x we couldn't put in this thing? Well, the answer to that is pretty much no. I mean, I could put in 1.5. I could put in 0.3578 as a decimal, and I would get a decimal. And so I'm going to go ahead and connect these the best I can, because you guys know me and drawing on this thing. We don't get along that well. So not too bad. It kind of looks like a line. So that line I'm drawing, I'm putting arrows on it because I know that there's no x value I can't plug into this function and not get an output. And every input-output relationship is going to fall on this line. Let's check on one in between just to show that. Let's try 1. So when x is 1, let's see what happens. So when x is 1, y equals 2 times 1 minus 1, or 1. So we get the point 1, 1, because y equaled 1 over here. And so when we graph that at 1, 1, again, that fell right on the line. So this line describes all input and output relationships for this function. This is what we would call a linear function because it's straight. And notice, this thing cut through the y-axis right here at -1. Again, this is what we would call linear. I'm going to give you one more example of a function that's not linear and show you how I approach that. And then you'll have an assignment when this is done. All right, here we go. One more example. Okay, so this is a different kind of function. And the way I'm going to know it's different is I'm going to graph it and then see that it's not a straight line. So we know it can't be linear. I'm not going to tell you what this is called yet. We're going to try to graph this one, and then there's going to be another one I'm going to ask you to graph in the assignment, and we're going to analyze these in class, formally name them, and see how they're different and how they come out in certain patterns, numerical patterns even. Okay, so if we wanted to graph this again, we would do our table. So I'm going to have my inputs. This is going to get me my output here in the middle, right here, and then I just want to keep track of the points that I get, so my x and my y coordinates. So let's start with a negative number, like maybe -3. When I plug in -3, it needs to get squared, so -3 squared. And the whole thing, all of -3 gets squared. So you need to think of it as -3 times -3, which results in a +9. So we have the point -3, 9. Okay? And what about 3? Let's plug in, well, let's wait on that. Maybe let's try -1 here. What happens if we plug in -1? Well, -1 squared is just going to be 1, because a -1 times a -1 is 1. So we get the point -1, 1. Let's try 0. We know 0 squared is just 0, so y is 0. But we want to try some positive values, right? And I'll switch colors for the positive values here. Let's try 1. Again, notice it's just going to come out to 1. So we have the point 1, 1. And let's try 3. So y equals 3 squared. Again, I'm plugging in my input into the place of x, if you feel like you have no idea where I'm getting these numbers. So this is 3, 9. So this is a pretty special function because it's very symmetric about the y-axis. Check it out. So I'll graph these in blue. If I graph the first point here, -3, 9, I go over 3 and I go up 9, which I think is right here. And if I do -1, 1, I get right here, 0, 0. No, I have 1, 1, and I have 3, 9. Huh. That may not be enough information to really know how to draw it. I mean, should I be connecting this point to this point with a straight line? Are they more curved? What's going to happen? And when you have questions like that, you can just plug in more inputs. So if we were to try 2, of course that would translate to a 4, because 2 squared is 4. If I was to try -2, that would translate to 4. So -2 and then 4. And 2 and 4. So it almost looks like it's a curve. And it's a curve that kind of mirrors itself right along this y-axis here. It's kind of the exact same look that it has on the left as it does on the right. So if I was to try and connect these, I would try to curve it just because I kind of have that intuition, I guess, and it looks curvy to me. And this is definitely not linear. It's not a straight line. It's a different kind of function, but it's still a function. So even if you get a rule that's non-linear, like this one, you can still come up with inputs and outputs and graph it. Okay, good luck to you guys. There's going to be, I think 3 or 4, I haven't decided yet, problems that I'm going to ask you to do tables and graphs for your homework, and bring those into class. You're going to need them for the lesson. Thanks, guys. Good luck.